Hello and welcome. In this PyMol3 tutorial, we'll be looking at how to display key binding pocket interactions without using a preset. By the end of this video, you'll be able to generate selections for a protein ligand binding pocket, understand the importance of including and excluding atoms and selections, and display, edit, and label polar interactions. Let's get started. This video follows on directly from the previous tutorial where we tried out some presets. We inspected the 5-IUY PDB structure, viewed the crystallographic density map, and then looked at a prepared version of the 5-IUY structure with hydrogen atoms added. Open your saved PyMol session file or load in the 5IUY_prepared.pdb file from the PyMol3 course data directory. I also have the original 5-IUY structure fetched directly from the protein databank in my PyMol session here. In the previous video, we applied the ligand sites cartoon preset, and we can see there are lots of polar interactions here. This looks pretty busy, and it would be useful to only highlight the interactions between the inhibitor of the CDK2 protein, and to ensure that there are no missing hidden interacting atoms or incomplete water molecules like we have with this preset. Although presets can be useful, we're going to focus on how to create binding pocket selections, apply styles, and display interactions without using a preset. We can begin with a default styling that's applied when a structure is loaded into PyMol, or by applying the classified or simple presets, and if you're starting with simple, you might want to hide the ribbon and show cartoon. We can also color by spectrum to recreate the chain bow, the blue through red along the length of the chain rainbow coloring, and we can color by element to bring back the nitrogen, oxygen, sulfur and hydrogen coloring. Zoom in on the ligand and we're going to create a ligand selection for our 5-IUY prepared object using action, generate, selection and organic. Rename this selection 5-IUY prep_lig. We can see the pink selection squares here. I'm also going to color the ligand using the by element option with magenta carbons so we can see the oxygen atoms a little better. Looks good. Now let's duplicate this selection and do action, modify, expand by 5A residues. Then rename the new selection 5-IUY prep_pocket. Show wire to see what's included in this selection. The ligand and all water molecules, and full residues that have any atoms within 5 angstroms of the ligand are now part of this pocket selection. Great. To display the polar interactions within our pocket, we can do action, find polar contacts within selection. Oh dear, we can see that this has doubled up a lot of the interactions. This is because our pocket selection very literally included all water and residues that are within 5 angstroms of the 5-IUY prep ligand, and even though it was not visible, this included atoms within our unprepared 5-IUY object too. We can see this in the sequence viewer if we toggle on and off our 5-IUY prep pocket selection. All of the binding pocket atoms in both objects are part of this selection. Don't worry though, we can easily fix this by doing action, modify, restrict to object, and then choosing just the 5-IUY prepared object. Phew. Let's delete and retry that polar contact selection. That's better. We've managed to effectively recreate the ligand site cartoon preset here, so it still looks a bit cluttered. Undisplay the polar contacts and let's try to highlight the interactions that only involve the ligand. Next to the 5-IUY prep lig selection, choose action, find polar contacts to others excluding solvent. To others excluding solvent is showing us only polar contacts from our selection, the ligand, to other atoms in the same object, but not solvent. If you play around with some of the other find options here, you can really begin to understand the importance of carefully defining our selections and the importance of Boolean operators and, or, and not, when generating selections and finding interactions. Let's also go ahead and show the labels for these ligand-specific polar contacts so that we can see the distances in angstroms. You may also have noticed that there are many other kinds of interactions and contacts we can look for, such as salt bridges, pi interactions, and even clashes. Finally, let's use the Hide submenu next to our 5IUI prepared object and choose Hydrogens Non-Polar to hide all of the non-polar hydrogens, since these are not implicated in any of the interactions we are looking to highlight. This is looking a lot cleaner, and with our prepared structure, we can now clearly see what are likely the key hydrogen bonds between this inhibitor and the CDK2 protein. Although the presets all have their uses, the modifications we have made do a much better job of showing off some of the specific science of this binding pocket, which is exactly what we wanted to do here. And if desired, we could make some additional selections for things like binding pocket water, so we can customize things further. Once you're happy with your edits, don't forget to save your session. In this tutorial, we have created selections, found interactions, and displayed labels, all using the GUI. A powerful feature of PyMol is that we could also perform all of these actions by typing commands into the command input area, or by writing a script to automate the process. For online course participants, a list of the commands is available in the downloadable transcript for this video. Have a go at redoing this tutorial with commands, and check out the selection algebra, property selectors, single word selectors, and colouring references on the PyMol wiki for more guidance here. That brings us to the end of this tutorial. You can now generate selections for a protein ligand binding pocket, understand the importance of including and excluding atoms in selections, and display, edit, and label polar interactions. Thanks for watching.